Hi everyone, so today we are going to look at carboxylic acids. So carboxylic acids is what you get when you oxidize an alcohol. Okay, so let's look at it. So the functional group of the carboxylic acid is known as the carboxyl group. So the carboxyl group is also, you can call it the COOH group, but we can draw it as C double bond OH. Okay, a common mistake is when students add in the carboxyl group, they add in an additional carbon. So please be careful to check that the total number of carbons remains correct. Okay, so let's draw the 4 different groups. You may pause the video over here, right? And then I'll unpause it once you're done to check your answer. Okay, see you soon. Okay, so you should have drawn all of the different structures for the acids, and you can see, just be careful that for metanoic acid is 1, right? So there must be only 1 carbon. Ethanoic acid is 2, so there must be only 2 carbons. Propanoic acid is 3, so there must be 1, 2, 3, and so on and so forth. Okay, just be careful about that. And then this is the structures. So over here, this is the structural formula, and you must have noticed by then that all of them needs to have a COOH at the back. Okay, and then we will start, and then you see the first one, there's no C, so we have to have a CN, a H, 2N plus 1 when N starts from 0, 1, and 2, and 3. Okay, so for the first one, N is 0, so we got a H, and for the second one, N is 2. Okay, so let's look at that. Alright, so now carboxylic acids are weak acids, so meaning that they partially dissociate in water to produce H plus ions. So therefore, carboxylic acids are soluble in water, and like alcohols, their solubility decreases as it gets bigger and bigger and bigger. However, because they are acids and acids produces H plus ions when dissolved in water, they are electrolytes, meaning that they can conduct electricity. So it's a special type of simple molecule that can dissolve in water and conduct electricity at the same time, similarly to acids. Right? And carboxylic acids are also liquids at room temperature, so like alcohol, but not like the alkanes and the alkenes. Okay, so if you look at the structure here, carboxylic acids are weak acids. So we have actually this H over here, and this H is what we call the acidic hydrogen. So if you look at over here, we got one COOH group, and because we have one COOH group, this is monobasic. So what happens when it dissociates? It will form something like this. There will be a negative sign here, plus a H plus, and then we'll fill up the rest with hydrogens. So this is how a weak acid, this is propanoic acid, dissolves in water to produce H plus ions. Okay, so take note, there is only one acidic hydrogen. Alright, now, so carboxylic acids is like acid. So if you take note, like nitric acid, whatever you react with will become nitrate. Sulfuric acid, whatever it reacts with will become sulfate. So ethanoic acid, whatever it reacts with becomes ethanoate. Okay, so this one is something that you need to go and remember, because this will help you decide what are the compounds that are being formed. So let's take a look. Okay, so let's give an example, maybe magnesium. So magnesium, remember the big Mac, MAC, so magnesium plus, let's say, ethanoic acid. So magnesium plus metal plus acid gives me, let me put this aside, metal plus acid gives me salt and hydrogen. So the salt would therefore be magnesium ethanoate, okay, plus H2. So let's write the chemical formula. So it is like this. Ethanoic acid would be CH3COOH. So how are you going to write this formula over here? You're going to write it the same way. So Mg CH3COO2 plus H2. And then we balance this, and then we get this, like that. Okay, so magnesium ethanoate. Okay, so the ethanoate ion is a negative ion, right? So next one, carbonates. So carbonates plus acid. So I want you to notice this ethanoate, right? This is an ionic salt. So let's write this down. This is ionic salt. So it's a magnesium ethanoate. Okay, so carbonates. Let's do sodium carbonate. So Na2CO3 plus let's say methanoic acid. Okay, I'll form sodium methanoate. So let me just write down the name. Sodium methanoate. It's a product formed from the acid. And then H2O plus CO2. So sodium methanoate will be Na, and then we have HCOO. You can draw a bracket. This one will be fine, right? Just to show that it is something like that. Lastly, bases. Let's do potassium hydroxide plus CH3COOH, and then it will form potassium, and this is ethanoic acid, right? So we form ethanoate. Okay, so sodium ethanoate plus water. So potassium ethanoate is K, then CH3COO. Okay, sometimes you see some books they put the K at the back, so usually I also prefer that, to put the K at the back. Okay, so these are the acid reactions of carboxylic acids, and these are the one that forms the ionic salt. So these are actually acid and base reactions of carboxylic acid. So these are the acid reactions. Now, carboxylic acids also have certain sort of reactions that are actually the organic reactions, and that is something that we'll look in the next video. Okay, so go and revise. Make sure you know how to write the formula, the name, and all that, and then I'll see you for the next video. Okay, bye.